You hear about AI learning all the time, but what does that actually look like? It's definitely not magic. Today, we're going to pull back the curtain and break down the 5 core ways machines learn, the strategies that power everything from your phone's photo app to the most advanced AI on the planet. Let's get into it.
And that's a great question, right? The answer isn't just one thing. It's a whole toolkit of brilliant strategies. Think about how we learn. Sometimes you have a teacher walking you through things, sometimes you're just exploring on your own, and sometimes you learn by good old-fashioned trial and error. Well, it turns out machines kind of do the same thing, with different methods for different jobs.
All right, first up is the one that probably makes the most sense to us. It's learning with a guide. In the biz, we call this supervised learning. This is our first of the 5 methods, and it's basically like giving the machine a complete answer key right from the start.
Seriously, think about studying for a test with a huge stack of flashcards. On one side, you have the question, that's the input. And on the back, you've got the correct answer, that's the known output. The machine just churns through thousands or even millions of these flashcards until it starts to see the patterns.
But here's the real trick. It's not just memorizing. After seeing a million pictures labeled apple and a million labeled banana, the machine starts to understand the essence of what makes an apple an apple. The real test, the whole point of this, is when you show it a brand new picture it has never, ever seen before, and it can correctly say, yep, that's a banana.
So learning with a teacher is fantastic, assuming you have that perfect labeled data set. But what happens when you don't? What if your data is just a giant, messy, unlabeled pile of stuff? Well, that calls for a completely different playbook, which brings us to method number 2.
In this situation, the machine is basically thrown into the deep end. There's no answer key, no teacher, nothing. This is unsupervised learning, and it's all about one thing: finding the hidden structure and making sense of total chaos, all by itself.
The best way to picture this is to imagine a librarian who gets a truckload of books just dumped in a massive pile on the floor. With no instructions, what would they do? They'd start grouping them, right? All the big novels go here, the comic books over there, and maybe a separate pile for the really weird ones. That's exactly what unsupervised learning does.
So the main goals here are about discovery. Clustering is just that, finding those natural groups, like our librarian did. Dimensionality reduction sounds complicated, but it's like taking a super complex report and boiling it down to one simple chart that tells you the main idea. And anomaly detection? That's about spotting the odd one out, that one weird book in the pile that doesn't fit anywhere. In the real world, that could be a sign of credit card fraud or a major problem in a system.
Okay, so we have learning with the teacher and learning all on your own. But there's a third, really clever method that has become absolutely fundamental to modern AI. It's called self-supervised learning, and it's where the machine literally figures out how to teach itself. So what it does is pretty ingenious. It creates its own little puzzles from the data it's given. It'll take a sentence, for example, hide one of the words, and then challenge itself to guess what's missing. Every time it gets it right, it reinforces its own understanding of language and context. It's an incredibly powerful way to learn from the trillions of words on the internet, and it's a huge reason why large language models understand grammar and facts so well.
All right, quick recap. We've got learning with a teacher, learning alone, and learning by teaching yourself. But what about a hybrid? A more practical, real-world approach. Because often, you have a little bit of expert knowledge, but nowhere near enough to label everything. And that brings us to our 4th method, semi-supervised learning.
Honestly, this is such a practical solution to a huge problem. Think about it. Paying experts to perfectly label millions of data points is insanely expensive and takes forever. So with semi-supervised learning, you use a small, really high-quality set of label data to kind of kickstart the process, and then you use that knowledge to guide the analysis of a much, much bigger pile of unlabeled stuff.
Let's say a university wants to sort thousands of student essays. They might only have the time and money to have professors carefully grade 5% of them. Well, semi-supervised learning can take that tiny, expertly graded 5% and use it as a guide to make really smart guesses about the other 95%. It boosts accuracy like crazy without breaking the bank.
So far, all the methods we've talked about deal with data that just sits there, waiting to be analyzed. But our 5th and final approach is completely different. This isn't about learning from a static data set. This is about learning by doing, by interacting with the world and learning from your mistakes. This is reinforcement learning. So here's the setup. You have an agent.
That's our learner, and it exists in some kind of environment. The agent tries things, it takes actions, and for every single action, it gets feedback. It gets a reward for a good move and a penalty for a bad one. It's just this constant loop. Try something, get feedback, learn, and try again.
The perfect example is a robotic vacuum cleaner. If it successfully cleans a spot, it gets a little reward point. If it bumps into a table leg, it gets a penalty. Over thousands of attempts, it's not just trying to get 1 point, it's learning a whole strategy, an optimal policy, to clean the entire room as efficiently as possible to get the biggest total reward.
So why does all this matter? Why go through these 5 methods? Because these concepts, especially the powerful duo of self-supervised and reinforcement learning, are the very engine that makes the incredible generative AI tools we use every single day possible.
And here's how it all comes together. First, a huge model uses self-supervised learning to just inhale massive amounts of text and learn the patterns of human language. But that only teaches it to predict the next word. Reinforcement learning is that critical second step that teaches it how to use all that knowledge to be helpful, to be coherent, and most importantly, to be safe.
This right here is the secret sauce, reinforcement learning from human feedback, or RLHF. In this case, the reward isn't some point in a video game. The reward signal comes from actual human beings. People look at the AI's answers and rate them, basically telling it, yes, this was a great, helpful response, or nope, this was wrong and unhelpful.
At the end of the day, this whole process is about one thing: aligning the AI's enormous brain with our human values and what we actually want it to do. This is the step that teaches a model to say, I can't help with that harmful request, or to ask for clarification instead of just making a wild guess. It's what turns a powerful prediction machine into a genuinely useful tool.
So there you have it. From a simple teacher-student model to the complex feedback loops of reinforcement learning, these are the real building blocks of modern AI. They've given us the incredible power to teach machines, but they also give us a profound responsibility. Because as we get better and better at this, the question isn't really can we teach them anymore, it's what should we be teaching them next?